Yeah, I can hear you.
So uh, basically what we discussed in last lecture is data structures and algorithms. So as you all know, when it comes to programming, then there are two things. First is the data, and second is procedures. So basically, when it comes to programming, we generally start with like microscopic scale. We think about making it more modular and abstract friendly, and then from there onward, we try to think of ways using which we can make it more complex. Okay. So today we will just think about data and how exactly we can make it more complex using DCAP principle, and based on that what we can get. Okay, so that's something we discussed actually in last lecture only. So we got certain data structures. Few of them were linear, few of them were non-linear or unordered. So in last lecture we saw two types of data structure. So linear one are those where all the primitive data elements. So basically data structure is kind of a container, or it's kind of collection where we put certain primitive data elements together, and combine means when we put them together in one container, we put them in such a way that it means we should be able to like deal with that data more efficiently. Okay, like if we have to like store data from like 50 students, so in that situation we might need to create 50 variables. Okay, so instead of creating those 50 variables, what we generally do, we tend to create one array. So data structure is something helping us to expedite this procedure, helping us with like do programming in more efficient way. So in last lecture we discussed two kind of data structures. First one are like linear one and non-linear one. In case of the linear data structure, all the primitive data elements are at like one level. Okay, and mostly they are stored in contiguous memory locations. So, and then there is a second class of data structure, that's something called as like non-linear or unordered data structure, in which basically primitive data elements are stored in hierarchical fashion, and all the data elements are generally stored at different levels. So in case of the, let's check these two kind using certain like characteristics. Okay, so in case of the linear data structures, we have some Python inbuilt functions. Okay, so we have list, we have tuple. Okay, so in case of the tuple, those are like immutable. So as you can see over here, so m is equal to, so basically we put them in a parenthesis, and there are those data structures or the elements inside that data structure are like we cannot change them. Okay, so tuple is a data structure which is of linear kind, and that's something immutable. Immutable. Okay, so that's the first thing. Then there is a second data structure, that's something called as like array or Python list. So basically again it's a linear kind of data structure, but thing is that here data means this data structure is mutable, means you can change particular data element from this data structure. Okay, so like at location 1 if you are having 3, then we can change that data element to another value. Okay, but that thing is not possible in case of the tuple, which is possible in case of the arrays. And then related to the list or array, there are certain methods which are available in Python. Like we have append function, we have extend function, we have sort function when it comes to numeric numerals. Then we have reverse thing. So basically using these methods, we can like do certain operation on this list kind of data. Okay, then we have non-linear data structures. Okay, and that's something called as like set and dictionary. I'm just talking about like Python inbuilt libraries which are available to do this data structure kind of thing. So then we have like set and dictionaries. So basically set is like collection of unique element. Okay, so if you create collection, and if you're like having a mix of,
Mayur,
yeah.
just one question. What do you mean by non-linear data structure? Like, is it something related with the uh, a way with which we are storing the data, or something else?
Yeah, it's about that only. Actually,
Okay,
it's
okay.
about the way we store data, and it's also about how exactly particular element is related to another element. So it's also about
Okay,
relation as well.
okay, okay,
So
got it.
thing is that in case of the linear data structure, let it means if you talk about array, so in that situation, all the data elements are like stored in contiguous memory location. Okay, so this is the
Right.
linear data structure, right? Basically thing is that all the data elements are like stored in one at one level only. Okay, so if you consider array of 10 element, and if you consider like first and second element, so all of them will be like stored at like same level. Okay, but if you consider tree of 10 elements, So in that situation, you have like one root node, and then root node will have like certain child nodes. Okay, so it's like let's say you have like one. Let me draw it so that it will be much easier for you to visualize. So sorry for poor drawing skills. I'm just trying to explain this concept to you. So if you consider over here, I'm not considering about indexing the way we do in Python, but if you just consider this element to be 1 and if this element to be 2, then this has like third element. So if you see like all these elements means are at like at same level, okay, means they can represent one characteristics only. Okay, so if we consider it to be like length, then this will be like length only. Okay, but in case of the tree, we can write 1 over here, we can write 2 over here, we can write 3 over here, we can write 4 over here. So basically there exists relation between 1, 2, 3 and 4. Okay, so basically all of these elements are not at one level. Okay, so one is at like level 0, then 2, 3 at level 1, then 4 at level 2. So basically when I say like they are at different level, basically they represent different characteristics. Okay, so it could be like name of student, it could be like height of that student, it could be or like if it's like if you're talking about like mark sheet or something like that, then this first layer could be like about subject, then third layer could be about the mark that that student has received in that particular subject. Okay, so basically marks are related to subject, subject is related to student. Okay, so basically all of them are like really means at different levels. Okay, marks are at like level 2 only, but if we consider this like one single array, then we can put all means uh, we can generate that as like string, or we can generate that as like a collection of numerals, but basically we can create it as like collection of marks only, or we can create it as like collection of subject only, or we can create it as a collection of student only. So when I say like all of those elements are at like same level, basically that means like they signifies same characteristics. Okay, so that's how
If I'm getting you right, so basically you mean if we are taking list of suppose we are taking list of list, then we are talking about non-linear data, right?
no. So there are two properties that you have to think about. Okay. So in case of the list, we generally store that thing in a contiguous memory locations. Okay, and
Right.
thing is that like what you are saying, that's also true. Okay, when we talk about list of list, in that situation also like they are like stored at like different means in like means they are related to each other, but the way we think about them in case of the trees and the way we think about them in arrays is totally different. Okay, their significance is totally different. Here you have like one starting point. In case of the arrays also you have like one starting point, but the way they are related to each other, that's quite different. Here for each element you just have like sense of value, okay, sense of data, but in case of the trees you have sense of data as well as sense of reference. Okay, so that something is not present here in case of the I mean linear data type, and that something is present in case in case of like this non-linear or unordered data structures.
Okay. Okay. Got it.
So basically means this is something allow us to like deal with this data in like more dynamic fashion. Okay, means insertion, deletion, that's something become quite easy if we like put it in like BST fashion or something like that.
Right.
Yeah. So that's about that particular point. But yeah, I'll share like proper resource which distinguishes these two things from one another. So I'll share that with you. So then there is like non-linear data structures like set or dictionary. So set is basically unique collection of elements, and then dictionary is something where we have like key value pair. Okay, so in this case we can like create this collection where we will have like certain unique number of keys, and for each key there will be like certain value. Okay, and here also we can put them at like different level. So basically if you have to create dictionary, then that something can be created using like trees or like non-linear data structures. Okay. So basically, this is like a non-linear data structure which is available in like Python programming language by default. Okay, so that's about like linear and non-linear and what are like inbuilt function available in Python library. Then there is, in case of the linear class, we have like one more data structure, that's something called as a linked list. So in case of like this linked list, what we were saying, like in case of the arrays we just have like sense of data, but in case of the linked list we have like sense of data as well as like sense of like means that element itself knows where exactly is next element. Okay, but thing is that like all of those elements are like at same level. That's the reason we call it like extension of like list only. Okay, means basically two elements have like some sort of link existing between them, and that link is generally act as like means basically we call that as like pointer or something like that. So that's something act as a link between these two elements and binds all those elements together and create like one long list. So basically that's something called as a linked list. So that's like theoretical definition. That's something we discussed in last lecture. But thing is that when you have to implement that thing in practice, so in that situation, we need to like fragment that thing into like small pieces, and then we need to put it together so that we could get like a complex thing done. So in case of the linked list, what we are saying is like we are having elements, and those elements are linked to each other. Okay. So basically, what we are trying to do over here, whenever we have to define linked list, in that situation we try to create node element. Okay, we are trying to create element, and for each element what we are saying, it has sense of data as well as sense of like reference, or it will have pointer which is pointing to the next location. So first of all we will create class node. Okay, that's something we discuss in object oriented programming, and then inside that we will create one constructor. Okay, and that constructor will be defined like this. So we will initiate it with like data is equal to data, and it will carry pointer next, and that something will be like pointed to none by default. But what it means, basically we can point it to like another element, but it will have like these two attributes associated with this method. Okay, so or particular this object. So we will create node object, or we will write class, and using that class we can create node object. So basically this is the first thing that we have to do when we have to like develop linked list. Then second thing that we have to do is we have to create second class, and then we have to initiate that class with head instance variable. Okay, so basically linked list is something which start at some point, right? So we need to mention starting position of that particular linked list. Okay, and that's something we are doing using definition or like declaration of this linked list class. Okay, so first class to like create a node or elements, second to mention starting point. Okay, so this is how we can define linked list. These are the two things that we need. Once we are done with definition of these two things, the third thing that we have to do is we can like create instances of this class, and using that we can like create linked list. So first thing that we have to do, we have to initialize this linked list. Okay, so we create instance of this class. By default this method will be executed since this is like init method. So by default it will act as like constructor, means all those variables which are inside this init method will be get generated. And so what happened, so what we are doing is like we are creating a starting position for our linked list. Okay, so that self dot head will be generated, and yeah, that will be stored into list object. Okay, so that's the first thing that we are doing. We are like we have started working on developing linked list. So first thing that we are doing is we are creating head. Second thing that we have to do is we have to point that head to some node element. Okay, because that's like just like some location that we are pointing to, but we need to store something over there. Okay, so what we are doing, we are storing that list head equal to node 1. So basically we are creating first element, we are creating first node, and we are assigning that thing as like first element of our linked list. Okay, we are considering that as like head. So that's something we are doing over here. So first of all create element with like some empty location, and then create element and put it in that location. So that's how we are getting like first element. Then we can create like as many as element as we need. So we are creating node 2, so basically second element. Then we are creating third element. So basically we create new element and we store it in like some variable. Okay, so we basically that's something act as an object. So we have created object second, we have created object third. The next thing is like once we are done with like definition of all those elements, and once we have declared linked list and we have initiated that with like node 1, the next thing that we have to do is we have to connect all those nodes to one another. Okay, so what we are doing is we are saying node like this linked list head dot next to second. Okay, so basically we are pointing first element to second, So as we discussed, like first element is something that will carry like pointer or to second element. Okay, so using this next variable, it's like pointing to the second object. Then second object will point to third object using second dot next method. So that's how we get like that list generated, and you can see like you start with what means that way we get like the particular linked list generated, and to print that linked list we will use this additional method. Okay, this method is something is not necessary to define linked list. This method is necessary to read the various element of linked list. So we have written down this function. Basically what we are doing using this function is, first of all we are checking whether we have like starting element or top element or not, or like just starting element or not for this particular linked list. We are storing that thing into temp variable, and then we have this if logic over here. What it means, what is the thing that is being checked by this thing is like it's just checking whether there is like starting element for this particular linked list or not. Okay, if that starting element is present over there, then what we are checking, we are checking whether that starting element pointing to the next element or not. Okay, so for first iteration, it will be like just self dot head, but in next iteration, it will carry the value temp dot next. So in second iteration, it will check. Okay, so is there any next element which is like next to the first element? So it will check whether there is second element or not, whether there is a third element or not. Okay, so that something is happening. So in the beginning, it check whether there is like where is the starting point, or like where is like means is there any start to that particular linked list or not, and then it check whether there are like other element present in that linked list or not. Okay, so that's something we are doing. So basically we are going element by element, okay, inside that linked list. And once we are on that particular element, what we are doing is we are just checking because when I'm saying like that's the element, so that element carries two properties. First is a data, and second is point to the next thing, next element. So we are reading this data property of this particular object name, or particular that of that element name, and that's something I'm printing. Okay, and once I'm done with that thing, what I'm doing is I'm for that particular element, I'm calling that next property, which is pointing to like next variable. So that next variable will be called, and that will be stored into temp. Okay, and that's something we are checking. Basically what we are seeing is like, okay, first element is present. Now means do we have like second element present in this list or not? Once we check second element, it will go for third element, fourth element, and that way it will like keep this thing going. Okay, so I believe like this is the thing. uh Kripanshu, is this clear to you?
Yeah, it's clear now.
Yeah, so thing is that first of all create a class with instance variable data and pointer next. Then create a class to appoint or assign head position. Okay, and then apart after that, point that head variable or head position to certain element one. Then create like number of element as much as you want to add in that linked list, and then point first element to second element, second element to third element, and that means keep doing that thing. So that's how you can get linked list generated. There are a lot of things that you can do with linked list, like you can means add element to it, like you can delete element from it and all that stuff. So yeah, that's something we can do. Means that's something you can do later on, but means that was the basic idea about how exactly linked list can be defined. Basically that's something we discussed in last lecture as well, but still we are like discussing this thing again. Then there are like two more elements which are there inside like linear category. That's something called as like stack and queue. So stack, the one that we see is like similar to the one we are having in real world. So you can consider that like stack of books, or like pile of anything. Okay, so basically what we do, if we are like talking about stack of books, in this situation like we put one book, on top of that we can put second book, third book, fourth book. So in this way we can like create that pile, and whenever we have to like take out particular book, we obviously we can take it out from like bottom of that particular pile. But thing is that what we tend to do is we tend to take it out from like top of that particular list, right? So if we consider that as like stack, then we generally take it out from the top, and that property is something the stack possesses. So stack has a prop. So basically addition is always something done at the top, and removal or deletion of the element will always done at the top only. Okay, so stack is kind of like, stack is something can be implemented either using arrays, or it can be implemented using linked list. So that's something depends on how exactly we want to use the stack variable. So that's about stack. So whenever we have to implement stack, so the first thing that we need to do, so obviously basically here we are implementing this thing firstly using linked list approach, and then we probably will also see it using like arrays approach. So whenever we have to implement this thing using linked list approach, so we need to create a class node. That's something means using instance variable this node data and next, or value and next. So that's something we have to do. The next thing that we have to do is we have to initiate that linked list at some location. We need to assign head location. So that's something we are doing over here. The third thing that we have to do is we have to like point that like variable head point to first element in linked list. Okay, and then there will be like some method to push and pop element from that linked list or that stack. So method of process of addition of like element to stack is called as a push, and process of removal of element from the stack is called as a pop. Okay, so these are the two operations that we do, and means there are like various way in which we can do that stuff. Okay, so let's see how exactly that thing can be implemented. So basically these first two things will remain same, okay, as long as we are doing this implementation using linked list approach. The next thing that you're seeing over here, so that's something allows to like insert element into that linked list, delete element from that linked list, and like then we will see like how exactly we can go about it. Okay, so this is the insert first. Okay, so if I'm talking about like inserting element to that particular linked list, and if I'm trying to implement that thing using linked list approach, and if it's stack, so in last lecture we discussed like whenever we have to implement anything using stack approach, so in that situation we try to maintain one variable called as a top. Okay, so that top variable is something which will be initiated at -1, and each time we add element to that particular stack, it will be incremented by 1, and whenever we remove element from that stack, it will be decremented by 1. Okay, so let's say whenever we have to, so basically in case of the stack, element addition and deletion will always happen at the like top. Okay, so it will always happen at the top. So sorry for this. So basically this is like first element, this is second element, third element. So this is a kind of stack, and then it keep on going in upward. It will keep on growing in upward direction. Okay, so basically what we try to do, we try to maintain one variable called as a top, and it will means we try to do that thing when like the stack is empty. Okay, so that variable is called as like top, and it will start with -1, and each time we add element to that thing, it will be incremented by 1, then 2. That means each time it will be incremented by 1 only, but by the time you reach over here, that variable will be having like value maybe 2. Okay, and whenever you have to do further push operation, that element will be means that top variable will be incremented by again 1, and that will be at 3, and when you have to push pop particular element from this thing, it will be decremented by 1, and that will be at 2. Okay, so thing is that whenever you have to add particular element to this linked list, and means at least to this stack, and if we are like doing this thing using linked list approach, so basically what we are doing is we are trying to create some sort of means, so basically linked list is something like this. Okay, so forget about this thing, like they are like in vertical direction for now, but this linked list is of this kind of thing. Okay, so for first it will carry pointer to second location. So this is like top position where we are trying to add element. So if you have to add element over here, and it's like new element, so in that situation what we try to do, as I mentioned earlier, so we start with cell dot head equal to, or that top equal to -1, and we keep incrementing that thing by 1. Okay, so by the time we reach over here, what we try to do over here, we try to first add next position to means we try to point this particular element to this element. So we try to do next element or new element dot next to like this first element self dot head, and then we try to replace that self dot head with this new element. Okay, so that's something happen when we are like adding any element to this thing. Okay, so that's something you can see over here. So whenever we have to add particular element over there, so what we have to do, first of all, whatever new element we are trying to add, so that element will be having its like own pointer. Okay, that something should be point to first element or top element that we are having in our stack. So that's something we have to do as a first operation. Okay, and the next thing, so that's something will be done. So there will be like link between newly added variable and like top variable of our stack, and then we will say like self dot head is equal to new element. Okay, means top variable is equal to like new element for now. Okay, so that's how we add element to that particular stack. So each time you add element, you have to ensure that new element is pointed to like top variable which is existed in that particular stack, and then you will define that new variable or new element as like top element using this self dot head thing. Okay, so that top newly added element will be self dot head. Okay, and whenever we have to delete this thing from this head, so basically what we are checking over here, we are checking whether like this top variable exists over there or not. So we are basically checking whether stack is empty or not. So if there are elements inside that stack, means if self dot head is like positive or like if it's true, so in that situation we have to delete. So basically what happened in case of the stack, it will remove variable or element from the top of that particular stack, right? So we will delete self dot head because over here, as I mentioned, so self dot head is like at the top of that particular stack. Okay, so we will delete that thing, means we will delete self dot head. So basically we are not deleting it as of now. What we are doing is like we are saying that element will be deleted, the top element, and that element is stored into deleted element variable. Okay, the next thing that we have to do, we need to increment our top variable, not increment, we have to decrement our thing. Okay, so that element, deleted element dot next, so that something will be like the variable that we are having at the top, so we have to increment that thing by 1. Means we need to check with means where exactly that element is pointing, and then we have to assign that as our like new top. Okay, so that way we can do this thing. Okay, so deleted element is like self dot head. Whenever we are deleting that thing, what we have to do, we have to check where exactly this self dot head is pointing, and then we have to assign that as a new self dot head. Okay, so this self dot head is for now stored into this deleted element. You can also type like self dot head dot next instead of doing like these two things, and you can store that thing into self dot head. So basically that way what you are doing is like you are deleting that top element. That's how you are performing that pop operation, and that element will be written like what element is being deleted, and apart from that your stack will be like means restored or like altered in a way that like next element will be like top of your stack. So this is like this first insert first is a push operation, delete first is a pop operation. Okay, and then this is a print list operation. That's something help us to like read values or like read that entire means linked list. So that's all about that. So whenever we have to implement this tag, what we have to do, we have to think about ways. Means first thing that we need to do is we need to first create linked list. Okay, so we need to create linked list and we need to initiate that self dot variable, self dot head variable. So that's something we are doing with the top. Okay, so here we are mentioning that as a top. So I told you like there are two. I mean there is a variable that need to maintain, and that variable called as like top. So basically for now we are creating that head to be like none. So with top is equal to none, basically with the head is equal to none, we are like initiating that linked list, and that will be stored in object called self.ll. Okay, and then whenever there is a push operation, we will call insert first method from that linked list, and whenever there is a pop operation, we will call this delete first method. Okay, means without using these two, means we can implement that thing, but just for simplicity, like I have like taken everything into this like one class only. Okay, that's how like I have created this thing. I could have like created child classes as well, but for now I have done this. So basically this push is like when we are adding element, insert first. Whenever we are inserting that thing, what we need to do, we need to take that element, we need to point that to self.head or top of our stack. Then we need to mention that like newly added element is our new top. Okay, so that's the first thing. Whenever we are deleting, what we need to say, like self.head or top is something we are now deleting, and where our top is pointing, I mean the next element in our stack is something will be our like new top. So that will like delete first operation, and that's how like this push and pop is being performed. And whenever we have to like develop particular stack, what we need to do, first of all we need to create like class stack. We need to create instance of this class tag. So since this is a constructor, it will create linked list with head is equal to like top. Okay, since it's none, so it will create like stack with like means with empty thing, means it will be like empty stack. Okay, then what we have to do, so we will create like a few elements. Okay, so this is how we are creating elements: first, second, third, fourth. Basically these are object. That's something we can consider as an element. The next thing that we have to do, we need to perform this pushing or popping operation. So what we are saying, like stack dot push is equal to, means these are the method available inside class, right? So stack dot push, that will something like perform this push method, and new element is something like I'm putting over here. Okay, object. So self dot push is equal to first, so that's something we'll add these three as like first element of that stack, then second, third, and fourth. So I'm pushing four element on that stack, 3, 2, 1, 4 in that fashion, and then I'm popping last element. So as I mentioned, the last element is something will be pop up. So that's something we'll done. Then I'm printing. So if you print this thing, then you will see this sort of thing. So first element is like 3, 2, and then 1. Okay, so it will like read it from like top, so it will like 1, 2, 3. So first element is 3, then second element is 2, and then first element is 1. Since it is iterate, it becomes kind of iterator, so it shows us in that fashion. So this is using linked list approach. When we go for like array based approach, in that situation it become quite easy. So we can define that entire iterable means as a like a list, and we can store it into L, and we can use those methods associated with list, like using L dot append. We can add elements. So basically we are doing pushing operation, and whenever we have to do pop, so basically we can just like pop last element from that thing. Okay, so since we can put it over here like -1, or we can put like count of like last or index of last element over here. Okay, so basically when I write L dot append 4, so I would be able to like add 4 over there, and when I put L dot pop 3, so third element starting from 0 will be like pop up, and I'll get like a new list, sorry, new stack. So that's like implementation of stack using arrays approach. Guys, is this thing clear to you?
Yeah, it's clear.
Yeah, Lucky, are you there? Lucky?
Yeah, Mayur?
Yeah, is this thing clear to you?
Yeah, it's clear.
Okay. Atharva, what about you?
Oh yeah, I got it.
Just wanted to know this thing, like where we are going to use the stack and this thing.
Means,
Are we going to use it in ROS?
okay, so thing is that means the data structure part is something I'm means conducting just for, means when you do programming. So in that situation, you should be like familiar with this thing. So we are really not going to use this thing in our like project or like anything. Rather, we will assume like you are good at programming, but instead of going for, means that's something we were assuming so far. But for now onward, means that's something I have included in our curriculum. So we are really not going
Okay.
to means use this thing anywhere in our project, but this is something will be beneficial for you if you know like about all these data structures and like their implementation, how to do that part. But
I
the
thought
ROS
like
thing,
we are going to use this thing in ROS. That's why I just
yeah,
asked.
means basically ROS thing implementation will be done in Python only. Okay, so if you are aware about all these data structures and how to create all that stuff, then like means it's okay. But according to my knowledge, means entire knowledge about data structure is really not needed inside ROS directly,
Okay. Uh-huh.
as long as you are not going for like advanced algorithm related to A star or something like that, means
Okay.
related to graphs or something like that. In that situation only you need to know about this part, like how to do this implementation. But yeah, so next data structure is a queue. So again, queue is the linear kind of data structure. All the elements are at like one level only. So thing is that this queue is again similar to the queue that we see in real world. Means the one that we are seeing outside counter, means outside vending machine or in front of like ticket counter. So in case of the queue, what happened, it work on principle of first in first out. So element will be always added. So in case of the queue, there are two things. Okay, so first there is like head, the one which is closer to vending machine or like ticket counter. So that's something will be considered as a head or front, and the one up means which is far away from the ticket counter will be considered as a rear or tail. So in case of the key, there are two, these are the two things that we need to consider. Okay, Then in case of the queue, process of adding element will always happen at the rear end or at the tail, and that operation is called as the in queue. Okay, so that's something I've written over here. So that have something I've defined as like new method. And process of removing element will always happen at the head, like front end, because what we are saying like first come first serve. Okay, means first in first out. So in that means way, first element will be pop up, and that operation will be called as like DQ. Apart from that, there is one more operation that you can do with Q, and that is like you can always observe what is the head element. Okay, what is the element which is present at like first location, who is gonna be served next. So that operation is called as a peak operation. So whenever we have to implement this queue using arrays approach, so basically what we do. So first of all, we create one class queue, create class name queue. Then we'll have like one constructor, that something will initiate this iterator head. Okay, or like basically we will create one array and we will call that as like means once some sort of container cell.storage. So cell.storage here onward will that array will be our like queue, and whenever we have to like print all the element of that thing, we can just print that particular array. Whenever we have to add like any element to that thing, or whenever we have to perform in-queue operation, we can just use append method, and we can put element that we want to add inside parentheses. That way we would be able to like add element to this queue. Whenever we have to remove it, we can perform dequeue operation. And while performing dequeue operation, what we need to ensure is that we are really not the way in earlier cases we were removing last element -1 or last element or like nth element inside that array. Rather, we have to delete first element from our array. Okay, so that's the reason whenever I'm performing pop operation, means whenever I have to delete first element, or whenever I have to remove element from that particular queue, I was saying like first or oldest element will be deleted. So I need to ensure that my index is 0. Okay, so that is a dequeue operation. So addition or enqueue will be done using append method, and deletion will be done using pop 0 method. And whenever we have to observe first thing, what we can do, we can just like assess that access that particular element using storage 0. So basically we are reading 0th element of that particular array, and that's how we are getting this queue thing done. So whenever we have to perform like means whenever we have to create queue, so basically this is a class, so we will create like instance of that class as a queue, and then we can perform like in queue dequeue repetitively, and we can get our particular queue build. So we are performing in queue 3 times, means we are adding 3 elements to that array, so that our new array will be like 1 2 3, and then we are performing one peak for one time, and then we are like performing dequeue twice, so means 2 element will be deleted from that, and then we are just printing that thing. Okay, so you can see like first element is something, so one is something was voltage